Difference, the researcher tested several state-of-art interpolation methods on SportsSloMo, only to find that their accuracy dropped compared to other datasets. Difference, transformers have been a game changer for video recognition, but their downside, heavy computation cost. Imagine processing an entire video frame by frame, even when most frames barely change, a massive waste of resources. Difference, this ORS uses a two-stage intervention framework. That is, one is rewriting prompts using a large language model. This ensures user inputs are modified to avoid problematic content. And next, injecting prompt-based interventions into diffusion model. So this fine-tunes the image generation process to prevent unwanted outputs. Yeah, with 2 times faster inference time, ASD is an exciting advancement that improves efficiency, flexibility, and realism in AI-generated art. Happy morning, dear friends. Here's yours, Dr. Rajanta. Welcome to Demystify with Ajay. Dear friends, today we are going to discuss another exciting episode where we break down the latest innovation in video analysis, understanding, and image generation. Dear friends, AI is evolving at a rapid pace, and today we explore cutting-edge research papers that redefine how we generate, process, and analyze visual content. From human-centric slow-motion sports videos to efficient video transformation and next-gen diffusion models, these breakthroughs are shaping the future of AI-driven content creation. Whether you are an AI researcher, an enthusiast, or simply curious about how machines see and generate visuals, this episode is for you. So let's dive in. Okay, the first session, it is on video analysis and understanding. And the paper is SportsSloMo, a new benchmark and baseline for human-centric video frame interpolation. Difference, imagine watching an intense sports match where every moment ever jump and every shot is captured in stunning slow motion. But creating such smooth and realistic slow motion videos is not as easy as it seems. Most exciting AI-based framework interpolation model struggles when it comes to human motion, as body shapes are highly deformable and occlusions are frequent. This is where this SportsSloMo steps in, a brand new benchmark that offers over 130K high-resolution sports video clips containing 1 million frames sourced from YouTube. Unlike conventional datasets, this one is built specifically for human-centric scenario, making it ideal for training AI models to predict missing frames with greater accuracy. Difference, the researcher tested several state-of-art interpolation methods on SportsSloMo, only to find that their accuracy dropped compared to other datasets. This highlights just how challenging human motion interpolation is. To tackle this, they introduced two human-aware loss function that improves accuracy. One is panoptic segmentation loss, which ensures the AI understanding the structure of the human body. And the next one is human key point detection loss, so which focuses on body joints and movement consistency. So the result, of course, a significant boost in performance across multiple models, making this a strong foundation for future AI-powered slow motion video application. Okay, in the next paper, it is Eventful transformers, leveraging temporal redundancy in vision transformers. Different transformers have been a game changer for video recognition, but their downside, heavy computation cost. Imagine processing an entire video frame by frame, even when most frames barely change, a massive waste of resources. What about the solution? Yes, Eventful transformers, a novel approach that identifies and reproduces only the path of the video that changed significantly over time. Instead of treating every frame as equally important, this model focuses on events, key moments where motion or objects changes. And of course, what's even better, Eventful transformers can be applied to existing model without retraining, and towards the result is 2 to 4 times computational saving and minimal loss in accuracy, and next better real-time performance for applications like action recognition, object tracking, and video understanding. With on large scale data set like ImageNet, VID and Epic Kitchens 100, this method proves that smart computation can be just as powerful as brute force. Okay, the next session, it is on image generation, and the paper is ORS, that is Open Vocabulary Responsible Visual Synthesis. Different AI generated images are everywhere. But what happens when an AI unintentionally creates inappropriate, biased or restricted visuals? Controlling what an AI should not generate is just as important as guiding what it should create. That's why researchers introduced ORS, that is Open Vocabulary Responsible Visual Synthesis, a model designed to filter out forbidden content while still allowing user to generate creative unrestricted images. Difference, this ORS uses a two-stage intervention framework. That is, one is rewriting prompts using a large language model. This ensures user inputs are modified to avoid problematic content. And next, injecting prompt based interventions into diffusion model. So this fine tunes the image generation process to prevent unwanted outputs. So this research is a huge step forward in responsible AI, ensuring that text to image models align with ethical and contextual guidelines across different regions, cultures and applications. Okay, next paper, it is Any-Size-Diffusion. Toward efficient text-driven synthesis for any size HD images. Different stable diffusion has revolutionized text-to-image generation. But that's the problem. Resolution matters. If you try generating images at different size, you might notice distorted composition, missing details or stretched objects. To solve this, researchers developed Any-Size-Diffusion, that is ASD, a two-stage pipeline designed to create high-quality, well-composed images at any resolution. And how about it works? Of course, any ratio adaptability diffusion, that is ARAD. So instead of training a single scale images, the model learned to adapt to different aspect ratios, improving composition. Fast, seamless, tiled diffusion, that is FSTD. So this technique allows AI to generate large images without artifacts, making it perfect for HD and Ultra HD content. And yeah, with 2 times faster inference time, ASD is an exciting advancement that improves efficiency, flexibility, and realism in AI generated art. Okay, the next paper, it is MVDream, that is multi-view diffusion for 3D generation. Different text-to-image model can create stunning 2D visuals, but making consistent multi-view 3D objects, that's a whole different challenge. Exciting 2D to 3D methods often fail at maintaining consistency across multiple viewpoints. And here, introducing MVDream, a multi-view diffusion model designed to generate consistent 3D representation from text to prompt by leveraging both large-scale 2D image dataset, and multi-view 3D datasets. So this MVDream balances, that is the creativity of 2D diffusion model, the consistency of 3D data. And dear friends, it improves upon existing 3D lifting methods and even enables few short fine-tuning meanings. It can be trained on personalized 3D objects while preserving structural integrity. And this technology paves the way for advanced 3D AI models, making it useful for game design, virtual reality, 3D content creation. With this MVDream, we are getting closer to AI-powered instant 3D modeling from simple text inputs. Okay, dear friends, as we have seen today, AI is redefining how we process, analysis, and generate visual content. Whether it's enhancing video recognition, creating human-like slow motion, sports clips, or generating high-quality images, these breakthroughs are paving the way for the next era of AI-driven creativity and efficiency. Which research paper fascinated you the most? Let me know in the comment. Okay, don't forget to like, share, and subscribe for more deep dives into the latest AI advancement. Until next time, keep exploring the world of AI. Happy learning, dear friends.